The sorting algorithms that we will cover are very easy, very straightforward. We do it step by step. The main point of learning the sorting algorithms so that we can understand that in which sorting algorithms is preferable for which case. So you see, these are some of the sorting algorithms, which what it does, it actually sorts an array or any collection of data. Okay, so first initially we'll talk about array, then we'll see that we can not only sort array but other data structures as well. And every one of them has different types of algorithm. The algorithms that you see here are actually much more applicable for arrays, or we can say strings in some cases as well. Now, first thing, the first algorithm that we will start with, bubble sort, very straightforward. It is the simplest sorting algorithm and works by repeatedly swapping the adjacent elements if they're in the wrong order. So what does it mean? So basically, step one, it compare each pair of adjacent elements, swap two elements. If not, it repeat the process until all the elements in the entire array is sorted. So 3 steps. So let's see the visualization. So this is one array and we will apply bubble sort. So first step, what it does, it compares two adjacent elements. What does adjacent mean? So these two are adjacent. In Bangla, we say pashapashi, okay? So it compares two adjacent elements, two adjacent elements, two adjacent elements, and so on. Now, what we will do, we'll compare the two adjacent elements, and then if they are not in the correct order, we will swap them. So the definition of correct order may change, but in this case, we will say that we want the array to be sorted from smallest to the largest. Okay, so that means the smallest element will be in the first location and the largest element will be the last location. So the sorted array will look like this. In the sorted array, it will look 1, 2, 4, 5. So this is our input and this is our output. Now what is the algorithm? Compare two adjacent elements if they are in right order. Okay, if not, swap them. Okay, let's see. So first iteration, we compare these two adjacent elements, okay, j and j plus 1. So are they in the right order? No, because we want from smallest to the largest. So we swap them. Okay, so you see this is the swap, we swap them. So it becomes 1 and 5. We swap position of these two elements using a temporary variable. You can use other swapping techniques. Okay, then we go for the next two adjacent elements. So we have compared these two elements, then we will compare these two elements, and we will compare these two elements. We'll keep going on like this. Okay, so what is the next two elements? Okay, so 5 and 4. Again, the same question, are 5 and 4 in the correct order? Obviously no, right? 4 should come front. So they will swap these two elements. And then we'll go for the next two, that is 5 and 2. So are 5 and 2 in the correct order? No. So we will swap these two elements. So after the first iteration, the array will look like this. So two things to notice from here. First of all, after the first iteration, okay, the largest element, that was 5, is at the last position of the array. Okay, and the number of comparisons we needed was totally dependent on the data. Okay, now let's see another example. So this is the first iteration. Secondly, we'll start from the, so this is done. Okay, we have found the largest element at the last location. Then again, we'll start from the beginning. Okay, we'll again compare these two. Are they fine? Yes, they are fine. One should be at front. Okay, then we'll compare the next two, 4 and 2. So are they okay? No, they are not okay. So we'll swap them. So it becomes 2, 4. Then 4, so 4 is also done. So you see, second, what happened, that among the smallest array of 3 elements, which one was the largest? 4, right? So in the bubble sort, we can say that after the swapping operation is done, 4 will be at the last location. And this is how the bubble sort work. Okay, in each iteration, it takes the sorry, in each iteration, it finds the largest element and it pushes it to the last position. So let's see another example. This is another example where we have a little bit larger array, 5, 4, 2, 1, 3. Now, again, what we do, we compare two adjacent elements. Okay, they are marked as blue. So 5, 4, 5, 2, 5, 1, 5, 3. And if you see, again, by doing the same operation, After the first iteration is done, okay, we have 5 at the last index or the last position of the array. So this is how bubble sort work. At each iteration, it will find the largest element, it will push it back to the last. Okay, and then in the next iteration, as this is already done, okay, it will go for the rest part. Okay, so the how the program decides this one, we will see in the code. So in this way, okay, let's go for the next one. So again 4 2 4 1 4 3, and again 4 in the second last position, and then 2 1 3, so 3 will be in the third last position, and finally we'll see the array will be sorted. So this is the approach or the algorithm of bubble sort. So not much complicated, is it? Now as you can see that if I give you this sequence of numbers 12 13 2 9 4 18 45 37 63, if I ask you what is the output of this bubble sort after first iteration given the following sequence of number. Now let me give a pause. So how to solve this one? Okay, so first of all, we know that in the bubble sort we compare the adjacent elements, right? So if we compare 13 and 2, obviously they will swap position. And then we'll compare 13 and 9, they will swap position. We'll compare 13 and 4, they will swap position. Okay, that means we are moving 13 from here. Then we'll compare 13 and 18, they will not swap position. Okay, then we'll compare 18 and 45, they will not swap. 35 and 47, they will swap. Okay, so they will also swap position, and finally we'll have 63 at the last. So basically all the elements we have will be 2, will have 9. Okay, so if you just match the first two, okay, 2 and 9, you can easily say that the answer should be the second one, right? Because we are comparing whenever let me just break it down for you. So if I start with the first, so after the first two comparison, it will look something like this: 2 13, then 9 4, okay, and so on. Then we'll compare this two, so it will become 2 9 13 4. And you see, so we have 2 9 at front, and if you look at all the options, only one have 2 9 at front, so the answer will be B. Okay, so you don't have to actually go through, solve it as a whole, and that is that little bit tricky part. You have to be a little bit, clever to find the tricks. So I didn't ask you to solve all the part. You just have to find the answer, and you'll see that after just doing two swap or two comparison, you will see the answer. So then again, the answer is B. So try this at home and practice. Now, what is the code for the bubble sort? So we'll have a function called bubble sort where we'll take the array. The array will start from index I, that is 0, until the end of the array. So if the array length is 5, so it will start from 0 to 5, okay? Oh, sorry, 0 to 4. Then we'll have another index, that is j. J will start from again 0 index, but j will end at I minus 1. So basically when the value of I is 1, okay, sorry, I is 0, so this is I and this is j. So let's try to understand the iteration of this, okay? So when the value of I is 0, this loop will go 4, because the length of that is 4, minus I minus 1. So basically minus 0 minus 1, 0 or 1. So it will go up to 3. And then when the value of I is 1, it will go up to 2. When the value of I is 2, it will go up to 1. So why we're doing this? Okay. And then I'm answering this in a little bit. Okay. So let's come here. What we're doing, we're just using a if condition, we're comparing the two adjacent elements. Okay. If the element that is at the front is larger, we are swapping. Okay. So here is a swap function. Here is a comparison. And here is a loop which runs from j equals to 0 to up to array length I minus 1. Okay, so let's see why this is I minus 1. That means here we have a minus 1, here we have a minus 1, but why this I here? Okay, so to answer that question, we have to go back a few slides. So if you look closely, when we're doing the first comparison, that means when the value of I is 0, the first iteration, okay, we actually compared until the last element, right? But when the 5 was there, we didn't compare this one. Okay, we didn't have to compare this one. In the next iteration, we actually compared from this part to this part. In the later iteration, we compared these two only. If I go for the big example that we have seen here, if you look closely, in the first iteration, we have compared all the array. Second iteration, we have only compared this part. Third iteration, we have only compared this 3. And that's how it keeps going on. So basically every iteration, we actually shorten the array because we know that we have already found the largest element at the last. So we no need to compare this two. Okay, so that's why there is a minus I there. So this minus I helps us to do this. Okay, I hope this answers your questions. And finally, we have the main function. We declare the array. We call the function bubble sort, and then we print the array. Now you can try it in C or C++ any way you want, but the time complexity for the bubble sort is order of n squared. Why? Because you can easily say there are 2 nested loops, so n into n squared. And what is the worst case? That means what is the most amount of time that can take in a bubble sort? The array is sorted in opposite direction. That means you see here the array. Okay, let's first talk about the best case. What is the best case for bubble sort algorithm? The best case is the array is already sorted. You are trying to sort an array and the array is already sorted. Now you might ask, sir, why I will want to sort an sorted array? Okay, the answer is you might not. Okay, because sometimes whenever you have a data, you just want to process the data, sort the data. You don't have time to go through all the data. So some part of the data might be sorted already. So this is the best case. And what is the worst case? The array will be sorted in the opposite direction. That means you want 5 at the last position, but the 5 at the first position. So this is reversely sorted. And in this case, you have to actually do all the combinations, all the comparisons. And that's why this is the worst case. Now, that's what brings us to our ending of bubble sort.